All right, here's a good question. It says a gas is at STP. If they say STP, I know what the temperature is. It's 273.15 Kelvin. And I also know what the pressure is. It's 101.325 kilopascals. And they say they move it from a 5-liter tank to a 10-liter tank. Okay, and then they say the pressure is halved. So I have to take this and divide that by 2. So it'll be 50 point something. And then they say, what is the new temperature? And they also say no moles are changed, so the moles aren't in. So my formula, P1V1 over N1T1, so this is the combined gas law. And there's no moles, so I don't need to put I have an eraser. So no moles in there. And I'm trying to solve for T2. So T2 is going to be equal to T1 P2 V2 over P1 V1. So then I just plug the numbers in. So T1, 273.15 Kelvin. Pressure 2, it's halved. So whatever, I'll figure that out. 1.325 divided by 2. 101.325 divided by 2. 50.6625. So 50.6625 times volume 2 is 10 liters, divided by pressure 1, 101.325 kilopascals. That's kilopascals. And volume 1 is 5 liters. Now, if you look at these numbers, that's half, right? 10 divided by 5 is 2. And then this one is the other way. So really, both of those are going to cancel out. So if you multiply all this, it should come out to 273.15 Kelvin. So the temperature won't change. Now, just a sig fig thing. They only have 2 sig figs up there. So really, I should write this in 2 sig figs. It'd be nice just to write it as 3 sig figs, 273 Kelvin. But you need only 2 sig figs. So in this case, you'll have to change that to scientific notation. So 2.7, I could say 2.7315 times 10 to the second, if I move that decimal over 1, 2. And then I can round this to 2 sig figs, so it'd just be 2.7 times 10 squared Kelvin. All right, hopefully that helps you solve that question.